This is a Heathkit model C-3 condenser checker, also a capacitor checker. Back in the day they used the word condenser, and then later on they started using the term capacitor. I have to show you these tests in somewhat of a darkened room so you can see the tuning eye. It's kind of a compromise. So it might be hard to read the dials somewhat, but it's more important to watch the tuning eye action as I test some caps. I'm going to test several caps. I'm going to test electrolytic cap, and then I'm going to test some film caps. I recently recapped this unit. It's got all new film caps inside. I did some contact cleaner work on the switches, and it is operating very, very well. So our first test is an electrolytic test. You want to be careful to get the polarity correct. And by the way, I'm using gloves for a very specific reason, because during the leakage test you're actually putting voltage across the cap. So you got to be careful when you're using equipment like this. Below here, it might be kind of hard to see, but it says paper and mica. Paper and mica means a film cap. That's what they called film caps back when these were being manufactured. You want to set it on the electrolytic setting, which is not the paper and mica. There's a nice click to tell you that you're off of it, and I'll set it to the midpoint of the power factor at 30. And then we take our selector knob and we select 0.1 microfarads to 50 microfarads. This is a 50 microfarad cap at 150 volts. And then we sweep the dial until we get the tuning eye to open up to its maximum. And that's kind of maximum right there. Then we read off the dial. Now, this is reading above 50 microfarads. And that makes sense, because when capacitors get old, they go up in capacitance. That is pretty much the status quo of all these old vintage caps. They always go up in capacitance. So now we can conduct the leakage test. We're going to start by testing the leakage at 25 volts. So you might ask, what is leakage? Leakage does not mean the cap is physically leaking goo out of the capacitor. It means that it is leaking DC across the capacitor. Capacitors are supposed to block DC and allow only AC voltage to go through the capacitor. When you have leakage, you are leaking DC through the cap, and that is not a good thing for a lot of reasons. So we're going to test the DC leakage at 25 volts, and we're going to watch the tuning eye, and the tuning eye should close very quickly and then open back up. If there is no leakage at all, it will open up back to its original position. So just take a quick note of where the position is, how wide it is open, and you hit the leakage test and watch the tuning eye very carefully. It flashes quickly closed and it opens up. It's not opening up to its original size at all. So this cap is leaking even at 25 volts. Now remember, this is a 150 microfarad cap. So that's on the edge of this cap even being able to handle 150 volts. But hey, it's okay. We can do it, and it's barely opening at all. There's just a kind of a sliver of opening. It's definitely leaking DC. I don't dare go past 150 volts. So that is a capacitance and leakage tester on an electrolytic cap. Now we're going to test some film caps. These are actually film caps that came out of this unit. I recapped the entire unit, so I've got some of the old caps handy here. I'm going to flip this switch down to paper and mica, which again means film caps, and we're going to test one of the notorious Goodall caps. Okay, these are typically bad, believe me. I'm wearing gloves for a very specific reason, because I'm going to be putting voltage across these Goodall caps, and I could put as much as 450 volts across this cap. I would prefer to not get shocked. So we set the capacitance check to 0.001 microfarads to 0.5, because this is a 0.01, but they're in, two of them are in parallel, so it's actually 0.02. By the way, when I recapped it, I put in 0.02. So we sweep the dial and we wait till it gets open, and it's not really opening that well. It's opening somewhat. These old caps don't really open up that well. And here we are. We've got 0.02 here, 0.05 here. We're somewhere between the two. You know, maybe like 0.03. It's not halfway. Halfway would be 0.035. We're less than halfway, so we'll call it 0.03. You kind of got to get used to the scale and, you know, dividing things out and doing a little bit of math in your head. It's not a digital readout. We're on analog. Now we can do the leakage test, and we'll go for a 25 volt leakage test. And that opens up pretty well, and it opens up approximately to the original open level. So it's not really leaking at 25 volts. We're going to go to 150, which is a big jump, admittedly. And it is definitely leaking at 150. It did not open up to its original open condition at all. Again, Goodalls are not very good. I'd have to call them bad all. Now we're going to test these two huge 0.1 at 600 volts. I'm just going to test one of them, by the way. These were put into parallel to create 2 microfarads. So I went and put in a 2 microfarad at 800 volts. Again, you want to make sure you're on the papered mica, because this is a film cap. And we're going to go to 0.1 to 50 microfarads, because it's a 1 microfarad cap. 1 microfarad. And we're going to sweep dial. Find that open condition. It's nice and open right there. And look at that. We're right at 0.1. We've landed precisely at 0.1. This little checker amazes me at how accurate it really is. Even though it's totally analog, it's really, really accurate. So now we're going to go to do the leakage test, 25 volts. Wow. It took a while, but it opened up to its original position. So there's really no leakage. It wasn't perfect. It should flash pretty quick. We'll go to 150. And it opens up pretty well. Going to go to 250. These are big jumps. I mean, wouldn't you agree? 25 to 150 to 250 to 350. You know, it's a big jump. And here we have less of an opening, but it still opens, and we're going to go to 350. And even less of an opening, we're going to go to 450. I would say at 450, we are definitely pushing some level of DC through the capacitor. Now when you think about it, we've got 450 volts across this cap. We've got, in essence, a lot of drive right now trying to push DC through this cap, and we finally accomplished a certain level of DC leakage across this cap at 450 volts. Pretty cool, huh? And then this last guy, we're going to test a brand new film cap. So 0.1 at 630 volts. Ta-da. And we're going to go to 0.1 at 50 microfarads, and we're going to sweep the dial. Find the open condition. There it is. And again, it's landed dead on 0.1. Amazing. Now we're going to do the leakage test, and see how it just opened up quickly. It flashed and went even more open. There's no leakage. We're just going to go all the way to 450 volts. I feel confident with that because it's A, it's a new cap. B, it is a 630 volt capacitor. And it's a film cap. It's pretty bulletproof, right? You'd have to put a lot more than 630 volts to get any DC to pass through the cap. At what level? Unknown. So it opens up great, and there's no leakage to this cap. So that concludes the capacitance test. And then we're going to do a resistance test. And for that, we have to change the test leads to the resistor side. So it's pretty quick. We just go like this. And I'm going to test a 10K. $10,000 ohms. Setting will be at R. We're reading the very outer scale right here. And we got maximum opening right there. And look at that. We're exactly at 10,000 ohms. We can also test it at R times 100. Go down to R times 100. And that's pretty much maximum. And we're, again, very, very close to the 100 mark. Since we're at R times 100, that's the multiplier. 100 times 100 indeed equals 10,000 ohms or 10K. So there we've got a series of capacitor checks and a resistance check. And this capacitor resistor checker is operating very, very well.